Hey everyone, welcome to another Reasons and Resources episode. So as you can see by what's on the screen here, for this episode I'm going to take a look at reasons and resources for learning Haskell. Now Haskell was another one of those languages which is on my list to learn. So that's my reason for learning it. Now, apart from it, well, how did it end up on my list to learn? Well, a couple of reasons really. I keep seeing Haskell come up every year on the Stack Overflow survey, and so that's piqued my interest. The other thing is, and I've mentioned this book before and I'll include a link to it in the description, is a book called Programming Language Explorations, and there's a chapter dedicated to Haskell in that book. So at some point I want to actually properly learn the language, and so of course one of my other reasons for doing these videos is it allows me to record my own reasons and resources for learning the language for future use. So a lot of the times when I'm recording this material, it is actually for purely selfish reasons, and it's a great way of me documenting something for future exploration. So beyond, that reason, what other reasons might there be for learning Haskell that you might be interested in, or once I start to explore it myself, will motivate me to explore it further. So firstly, Haskell, as you can see up here, is a purely functional programming language. So I was trying to think what my first exposure to something which would be deemed to be either purely functional or very heavily on the functional side of things, and I suppose it would be Clojure. And so Haskell's another great language, I think, if you want to explore a functional programming language, particularly through the lens of a pure one, and because that can be quite helpful. I know when I was learning object-oriented programming, although I never used the language I learnt it in, which was see, it's gone now. I was just trying to think now. But basically the language I learned object-oriented programming language in was a pure object-oriented programming language. And I found that really useful, even though when I came to dabble with object-oriented programming, I did it in other languages. Smalltalk was the one that I was trying to think of. So I often think of Haskell in the same way, I think, as Smalltalk for that. Now, the advantage with functional programming, particularly when you're sort of forced to just use that as a paradigm, is that functions don't have side effects, so that can lead to more predictable bug-free code. Haskell also leverages something called lazy evaluation. So this delays the evaluation of expression until its value is needed, and which also avoids repeated evaluations. So that has implications for the efficiency of computations and the ability to work with sort of infinite structures as well. It's a statically typed system. There's a strong typing system, so that helps you catch errors when you're compiling, rather than you only finding errors until, say, runtime. And again, this will contribute to more reliable and maintainable code. As you start to explore the language, you'll probably notice that the sort of code you end up writing in the language looks quite concise and expressive. And once you really get to grips with the language, then that should help you make it easier to understand, easier to maintain. And what I found really interesting is, in a lot of languages, you don't always immediately see that there's multiple ways of doing the same thing. You might say, I'd see there's like 2 or 3 ways, maybe, but it doesn't become obvious straight away. For some reason, even in just the limited amount of Haskell I've looked at, sufficient for me to be able to sort of start to put together an entry on my Programming Polyglot web WordPress site, I did notice that I was seeing quite a few different ways of doing the same thing. So a good example here is with the factorial function. So the top line is just a type annotation, but then underneath it on this Wikipedia article, we've got all sorts of different ways you can do, you can implement a factorial function. So you could use recursion with the if then else expression. You could use recursion with pattern matching. You could use recursion with guards. You could use a list and then do a product of a list. You can use folds, and you can use this point-free style. And as you learn the language, you'll get to see the sort of advantages and disadvantages of doing all of these based on how your program might be structured or how your data is structured, those sort of things. So yeah, there's lots of really interesting things that you get exposed to as you explore the language, but it happens fairly quickly, I found myself, through sort of just looking at the language. The other thing that I found very helpful, and my big question mark over this is, I'm not sure at this point whether Haskell's a good language to learn first or not. I certainly seem to benefit from learning it, or looking at it, should I say, after I'd looked at other languages which have pattern matching in them. So yeah, it's difficult for me to make that evaluation if a reason for learning it would be as a first programming language. So not sure there, but certainly it's a great pathway, I think, for experiencing functional programming language. And you can see here on the Wikipedia articles number of notable applications, list of where it's used or has been used in industry, on the web, those sort of things. As with all languages, there's a number of criticisms for it. One thing I noticed with the language, if you look here, you can see that there's been a stable release for quite a number of years. So if that's something you really like in a language, where it's basically once they've got to a certain point, it's not messed with too much, then yeah, that's one reason you might want to learn it. I know some other languages are constantly evolving all the time, which can be a good thing, but it does mean that you may be constantly refactoring old code in the light of more efficient or better ways of doing it in the language. So I was quite interested to see that 2010. That's also really helpful if you're sort of digging out older learning materials, in as much as they, if they were created after 2010 and were based on this stable release, then the only thing you really have to worry about is whether there's in terms of the sort of the collective consciousness of the community, whether there's a better way of doing it rather than you having to do it a different way because the language has changed, if that makes sense. So yeah, something else that I did sort of notice. Something I haven't mentioned before, I think, in these videos is there is a Haskell wiki if you're interested. So it's a specific wiki for Haskell, so I'll include a link to that. And now let's have a look at some of the sort of more monetary or career-based or career capital reasons for learning this particular language. It's one of my favourite new phrases, career capital. So again, I always look at the sort of same 3 parts of the Stack Overflow survey. So first up, we've got most popular technologies, like where does it appear on that graph? So fairly far down at 2%. This is the one where things like JavaScript and HTML, CSS, Python are fairly high up. And if you want to know specifically what question was asked to get this data, then you can see over here. But yeah, it's quite deep down the chart. If we look at this whole idea of desired, required relationship as well, so yeah, admired and desired, should I say, and we try and find it, there it is. So again, there's quite a wide difference between the admired percentage, which is down here, 53, and the desired, which is 3.7. It's interesting to sort of contemplate, you know, the difference between those figures, what the implication might be for that, where it is on the chart overall, when you're sort of thinking about learning a language. And then finally, you know, payment. So yeah, top paying technologies, as we've seen on previous videos, which I've done this year, or done, should I say, after the last, or the most recent Stack Overflow, which will be the 2024 one. And there'll be a new one around June 2025, I imagine. But we've got Erlang, Elixir, so stuff on the beam, pretty high up here. Closure, which is on the JVM, Nim, Ruby, Perl, Scala, Apex. Scala's a really interesting language, actually. You can do both functional and object-oriented programming there. And then we have Haskell down here. So underneath Julia, before Python, and then you've got things like Fortran, COBOL and Lua above it, and underneath it, C#, TypeScript, Kotlin. So, yeah. And then if we look at the main resource for Haskell, so this is the main Haskell website. Again, great thing now, tons of resources for these languages, or the languages I've covered so far at least. But what I tend to do is, I think I've mentioned this before, I tend to look at the Wikipedia entry and the website sort of in parallel. So I mainly use this to give me an idea of the historical perspective of the language, who was involved with it, how it's evolved, what the most stable releases are, what it was influenced by, what it's influenced, those sort of things. Plus, you know, things like criticisms and other things that might be in the article. Whilst I'm looking through this, it just gives me a bit of a better lens to look through these. And I tend to do that with all languages that I'm curious about. So within here, we've got the usual, you know, getting started. So how you set up a development environment. Yeah. So, I mean, my route is normally to obviously install the tool chain for a particular language, get the tool chain running at the command line, sort of so that you can use it anywhere, and then in VS Code install the appropriate extension, in this case the Haskell extension, and then from there just make sure it runs on a command prompt inside of VS Code, so you still can code and then you can compile it or interpret it depending on which language we're talking about here. You'll probably find on a lot of systems there's like multiple ways of installing it now, so it's up to you really. But I always read this installation guide several times just to work out that I'm, you know, installing the most appropriate tool chain composition and doing it in the easiest way possible. So yeah, because some of you out there might already use specific installers as well when you're installing languages, so that can have an impact if you like to use certain installation tools maybe. So yeah, lots of documentation. So CS194. So this course they're recommending. So a pretty easy link there. There's also a what do you call it? Like a, I was going to call it a play pit, sand pit. What did they call it on the website? Playground. That's it. There's a playground, as with a lot of languages. Whoops. Yeah, so it's a great way to play around if you don't want to install it straight away. Just want to kick the tires on it. I use these sort of things a lot now, actually. Great for also testing code snippets. I find this particularly useful if you're trying to do, experiments in large language models, and you want to just test the validity of the code quickly, and maybe you don't have the compiler interpreter installed. Yeah, I find it's really useful for that. A number of community resources, actually, a lot of community resources, so that's cool. So other resources for learning, there's this book, and this is probably going to make, so I don't know if I've mentioned, you probably know if you watch other stuff on the channel. I love books, and one thing I make a point of doing is buying at least one programming book a year, probably usually more. If you watched an earlier episode of my Life in Objects series, you'll probably see that my sort of Christmas book I bought this year is a book on programming Lua by the creator of the language. I'm really enjoying that book, and I'm sort of committing myself to reading a chapter, at least a chapter a day. And so when I come round to buying a Haskell book for my library here, this will probably be it when I get round to doing that. Learn your Haskell for Great Good, but you don't have to learn the book. There's a copy online, which is cool. And we've got Real World Haskell as well, which is online. There's other resources you can tap. I don't know if anybody out there that has ever subscribed to O'Reilly. I mean, it's not free and it's not necessarily cheap, but I found it really useful when I was actively working in IT. Particularly in as a troubleshooter, to have a subscription to O'Reilly. I don't now, but I did for about, I'd say, 2 years, and then on and off intermittently prior to that as well. I signed up for a year here and there, and when I found I needed it, it's basically when I needed to read more than about 2 or 3 books a month. And then I find it was more economical to do it through that rather than purchase books. That's really why I started doing it. But there's a lot more on there than just the books, actually. But this is a book that I've seen come up quite a bit when they're talking about learning Haskell. Particularly, as you can see, if you're interested in the parallel and concurrent aspects of the language. And we have CAS 194. So Introduction to Haskell. So I'll include a direct link to that. If you remember, it was mentioned here. So I'll include a deep link in there. Then we've got a number of interesting videos you can check out. The Go-To Conferences channel is always an interesting place to look for just programming generally, but they do have one on their video talking about this book, Effective Haskell. And this is the Programmatic Programmers is another publisher which have got a long history of writing well-respected programming books. So they've got one on Haskell. Then you have the Computer File channel. They have a functional programming in Haskell episode, just under 10 minutes, 9 to 10 minutes. Also, they've got one on monads or monads, however you want to say that, which I think is you really need to understand properly to get the most out of Haskell. Then we have Developer Voices have an episode with Simon Peyton-Jones, who, if you've looked at this article, you'll see is mentioned in the design by list. So I subscribe to this channel. So interesting chat with him. There's something called the Haskell Interlude, which is a Haskell focused podcast. Then we have the Haskell track on exercism. They have a Haskell track, 107 exercises. I really enjoy using exercism actually, because what I find useful is across different languages you get similar assignments, coding exercises. So it's quite interesting to see how the same problem or the same function might be built in Haskell versus, say, Lua or Python or all the other languages that are on the site. So I sort of really enjoy using this tool to play around with coding exercises. And in some languages you get quite a large amount of tuitional content as well that's really useful. But it does vary from language to language. And then finally, shameless plug, there's this project I'm working on, which is more of a personal project that I was doing anyway, and I just decided to make it sort of public, which is this experiment I'm doing really with creating language learning materials that I might find useful based around the structure utilised in programming language explorations for exploring languages, but then using large language models to create coding examples and information content around that language. And so I've done it. I'm basically working my way through the programming language exploration book. So I'm going through the order in which the chapters are. The main chapters are on there, but then the smaller chapters which feature multiple languages I've also got through to. So in the book, the individual chapters run from Lua through all of these languages at the top line to Rust. And then there's smaller chapters on Erlang, Elixir. There isn't one in the book at the moment on Gleam, but I wanted to attempt to put together something for that. And then also Fortran. So I jumped around a little bit here, went ahead in one of the chapters, the smaller chapters, because I was interested in Beam languages, which Erlang, Elixir and Gleam are. And now I've gone back to following the chronologically the way the smaller chapters go in the book. So I think that this chapter is one on old legacy languages like Fortran, COBOL, those sort of things. So I'm starting to put entries for that. But the reason why I'm here now is not to talk about this, but just to show you there's one on Haskell. So I go through the same sort of thing. It talks about binding and scope in the language. Very, very, very simple examples. This isn't intended as a primary learning resource, really. It's more intended as a compare and contrast between different languages. So you can switch between them and sort of read a little bit about, on a really simple level, how binding and scope works in a language, how functions and closures, how frames, argument passing, those sort of things, with coding examples that you can experiment and run. Prototypes, classes, those sort of things, extensions, dispatch, and so on. Operators, all the usual things. And I do that for multiple languages. So there we have it. Hopefully enjoyed this Reasons and Resources episode where we're having a look at Haskell. Thanks once again for watching. Bye for now, and I will catch you in a future episode.